Okay, in this video, we're going to start going through the section 6.2 practice day. So, the first question deals with special triangles. You have to remember that if you have special triangles, 30, 60, 90, and 45, 45, 90, you need to recognize that you can determine the sides because they have a certain relationship. What is that relationship? Well, in 30, 60, 90, the side across, let me get my marker, the side across from the right angle is the hypotenuse, and that's going to be the 2A side. Let me just get my marker working. Okay, so that's going to be the 2A side. This is across from the 90, and in the 30, 60, 90 triangle, across from the 60 is the A root 3, and across from the 30 is the A. Now you've got to do some math here in order to get the other sides because I have been given this one. So notice, here's an equation. If I know that 2 equals 2A, then using that equation, so if 2 equals 2A, what does A equal? Looks like A equals 1. So that means that this side, and when I change my color, this side's going to be 1, and this side's going to be 1 root 3, or just root 3, and this side was always 2. Now I have the side values I need. Okay, the sine of 30, so don't forget you have SOHCAHTOA, and you can always write this down so that you have it right in front of you whenever you need it. So the sine of 30, so from 30's point of view, I need opposite, which is 1, over hypotenuse, which is 2. Cosine of 30 is adjacent over hypotenuse. Tan is opposite over adjacent, so get all 6. Sine goes with cosecant, flip that over. Cosine goes with secant, flip that over. Tan goes with cotan, flip that over. At this point, look and see where you have to rationalize. So I have a root 3 down in the denominator here. I'm going to rationalize it. Rationalizing should be the last step. I have a root 3 down here as well. Okay, I'm done. I now have all of my trig functions, and they're all rationalized as needed. Okay, let's go to sine of 30. So now we're going to come from this angle's perspective. Excuse me, sine of 60. So from 60's perspective, the sine is opposite, which is going to be root 3 over hypotenuse. Cosine is adjacent over hypotenuse. Tan is going to be opposite over adjacent, and then sine is the flip of cosecant, and vice versa as well. Cosine goes with secant, and tan goes with cotan. Okay, now you see there's a pattern here. So sine of 60 is the same as cosine of 30. So you can see there's patterns in math. At this point, I'm going to just rationalize what I need to. And I'm good. So that's all done. Now let's deal with the 45, 45, 90 triangle. So looking at that, I also have relationships. Those relationships are going to be A, root 2. Here is your equation. If 1 equals A root 2, what does A equal? I have to divide by root 2, and I have to rationalize. So A is going to be in the numerator, root 2, in the denominator 2. Okay, so this is root 2 over 2, and this is also root 2 over 2. So now we have all our values. Here's one value, second value, third value, which was given. Okay, so SOHCAHTOA is still applying. Sine is opposite over adjacent. Both angles, both acute angles are the same. Both values are the same. Same over same just equals 1. Cosine's also 1. Never mind, I lost my head. Go back. Go back up. Okay, sine is opposite over hypotenuse. So that's going to be root 2 over 2 over 1, which you don't really need the over 1. This is going to be the same. Tan is opposite over adjacent. Same over same just becomes a 1. Now we're going to do our flipping. Remember, sine goes with cosecant. This is 2 over radical 2, and I'm going to end up rationalizing it in a minute, so I'm also just do it right now because this is the second tier. That can leave, and I just get a root 2. Secant is going to be the exact same thing. I'm just going to write root 2, and if you flip over 1, you still get 1. All right, so we have all of those values. You need to know how to deal with special triangles. If you don't understand this, play it back again, a little slower, and pick it up. Okay, next thing. Find all 6. So I'm going to ask you a couple of different questions, so make sure you see what you're asked to do. Find all 6 trig ratios for angle theta. Provide exact answers as fractions and use Pythagorean theorem if necessary to solve for the missing side. Okay, doing the first one, I like to do it like this. So write down all of your trig functions. Okay, here's all my trig functions. Sine goes with cosecant, so I just write it right across from it. Cosine goes with secant, tan goes with cotan. Okay, sine of theta. From theta's perspective, sine is 12 over 13. Remember, SOHCAHTOA is your friend. It's no harm in writing it down if it helps you be focused. This is 5 over 13. This is 12 over 5. This is 13 over 12. This is 13 over 5. And this is 5 over 12. Remember to get these first and then just flip accordingly. I have no radicals, so there's no need to rationalize anything. I am good to go. Moving on to the second problem here. What I see is that I'm missing something. This is missing. I cannot proceed unless I have that answer. So what I'm going to do is I'm going to find that missing side using Pythagorean theorem. That is the side across from the right angle. So that's your C side. So C squared equals the square of the remaining sides or remaining legs. 7 squared plus 5 squared, that's 49 plus 25, that's 74. Remember, that's not C, that is C squared. C is radical 74. So I know I'm going to have to do some rationalizing when I get my 6 trig functions. Okay, so now do the same thing we just did before. We're going to say I need sine, I need cosine, I need tan, I need cosecant, and I need secant, and I need cotan. Okay, get all 6 first, then rationalize. Sine is going to be opposite from theta's point of view, opposite over hypotenuse. That will need rationalizing. Don't do it yet. Cosine is adjacent over hypotenuse. Also will need rationalizing. Hold off. Tan is opposite over adjacent. Okay, get your reciprocal functions. Root 74 over 7. Root 74 over 5. And 5 over 7. Now go back and rationalize only when you have a radical, in the denominator. Okay, so what am I getting? 7 root 74 over 74, 5 root 74 over 74, and I am done. Okay, so that's how you do those. If you need to find the missing piece, you've got to do that first. Okay, that brings us to problem number 3 on the next page. Okay, I'm going to say draw triangles. These are all going to be right triangles. Angle theta is an acute angle in a right triangle. Get your right triangle. Now, they say it's an acute angle. That means it could be here or it could be here. it doesn't matter. You'll get the same answers. I tend to work on the bottom of the angle of the triangle. So I'm going to put this right here. Whoops, sorry. I'm going to put this right here. That's my theta. Where tan is 5 over 10. Okay, so I'm going to do SOHCAHTOA again over here. Okay, tan from this angle's perspective is opposite over adjacent. That is key because that's how you are putting the values on your triangle. All right, this says find all 6 trig ratios, but before I even start, I have to get this missing side. This is opposite the right angle, so this is going to be the C side. Okay, so given that, what am I going to do? I'm going to say C squared equals 5 squared plus 9 squared, and 5 squared is 25, 9 squared is 81, this is 106, that is C squared. I want C radical 106, and I'm good. Okay, so now get your 6 trig functions. So I'm going to say, okay, I need sine of theta, cosine theta, tan of theta, and then I'm going to have to also get, right, secant of theta. I want to do that. I want to put it opposite so that I don't confuse myself. This is cosecant of theta, secant of theta, and cotan of theta. Okay, sine of theta is going to be 5 over root 106 from theta's perspective. Cosine is 9 over root 106. Tan is 5 over 9. Get your flips. 9 over 5. Radical 106 over 9. Radical 106 over 5. Go back. Rationalize where needed. That's going to be 5 radical 106 over 106. This is going to be 9 radical 106 over 106. And I have all 6 trig functions. Okay? Okay, let's do another one. Looking at angle B as an acute angle in a right triangle. Do the same thing. Draw your triangle. Boom. Here's my right angle. I'm going to put my beta down here. So technically, hold on a second. Technically, this is your beta here. It's an acute angle and right triangle such that cosine is 7 over 10. SOHCAHTOA. And we're going to need to get missing side. This is what's missing. I'm going to call that the B side. Okay. C squared equals A squared plus B squared. C squared will be 10 squared equals 7 squared plus B squared. That's 100. This is 49 plus B squared. B is going to end up being radical 51. I'm assuming that you can do that. They want all 6 trig functions again. So again, I'm going to say sine, and this time I'm going to say sine beta, cosine beta, tan beta. Sine goes with cosecant. Cosine goes with secant. Tan goes with cotan. Sine beta is radical 51, because this was radical 51, over 10. Cosine beta, 7 over 10. Tan beta, radical 51 over 7. Okay? Now I'm going to move this over just a little tiny bit. Let me go like that, because I see where the rationalizing has to happen. And looks like that, let me see if I can move this. Yep. Okay, it looks like that is going to need to be rationalized. Let me get my pen back. Okay, so this is going to be 10 root 51, and then I'm going to go ahead and rationalize it. So I have 10 root 51 over 51. And then I'm going to flip this guy, and that's just going to be 10 over 7. And then this guy is going to be 7 over radical 51. And I am going to rationalize. There you have it. Okay, so let's do, well, I think I'm going to stop here, and I'll do another video with the rest of this material.